Hey everybody, quick video on how you find a slant asymptote. So we know there has to be a slant asymptote because the degree of the numerator is 1 greater than the degree of the denominator. And we further know that that slant asymptote is going to have a slope of 1/3. Think about this from an Algebra 1 perspective, not an Algebra 2 perspective. Think about what this, just the leading terms from each of those polynomials, the numerator and the denominator, think about what that would simplify to. It would simplify to x over 3, which is 1/3 x. So I know I have a slant asymptote, and I know that it has a slope of 1/3. But my question is, how do I figure out what its y-intercept is? If I want to put it on a graph, I need to know where it goes. So the way we're going to do that is we're going to actually divide. So we're going to do polynomial long division. Hooray, it's back on this as a division problem. Now, the first step should be relatively obvious. You know, what do you multiply 3x squared by to get x cubed? Well, we just did that. It's 1/3 x. So that'll give us x cubed minus 4x. Be careful with your degrees, powers, exponents, however you want to think about that, because we did skip over the linear term here. When we do that subtraction, we're going to get negative 2x squared plus x. Now, putting 3x squared into negative 2x squared would be negative 2/3. Which would give me negative 2x squared plus 8. Again, that's going to skip over the x. I almost missed that. And when I do that subtraction, I'm going to get x minus 8. So the quotient here, that is your slant asymptote. That negative 2/3 that you found is the y-intercept. You don't actually need the remainder, but if you wanted to write this out, you would write it out as 1/3 x minus 2/3, and then just like we did, in the polynomials, plus x minus 8 over 3x squared minus 12. Again, your slant asymptote is just the quotient part. But there are certain things where you might want to know what is going on with the remainder. We'll talk about some of those, but they're just kind of some points of interest. All right, I hope that was helpful.